We are on topic 4, and we are going to be talking about the quadratic formula and the discriminant. And we're going to be solving. So I hope that you remember that solving means to find the roots or the zeros or the x-intercepts. And specifically, with the quadratic formula, we're going to be talking about those that are quadratics, which means they are x-squared functions. So we have been finding zeros using factoring. Not really, but we've been using factoring to get to the point where we could find the zeros. We've been looking at the shapes of these functions and deciding what degree are they. We've been thinking about where the zeros are in a graph. So if I gave you a graph like this and I said, where are the zeros? You would tell me, Miss Vogt or Miss Delmont or Miss Herod, there aren't any zeros because I don't cross the x-axis. But how can I find zeros that aren't on the x-axis? Those are those imaginary zeros that we've talked about, like plus 5i, minus 5i, that kind of stuff. So how do we find those? So that's kind of one of the bigger parts of the quadratic formula. So I wanted just to show you my reasoning when I come across something like this, and I want to do this two different ways. So one way I'm going to factor, and the other way I'm going to do the quadratic formula. Now hopefully you remember the quadratic formula from Algebra 2 and from functions and trig. I wrote it here for you as well. This is review. But also if you wanted to memorize the song that goes with Pop Goes the Weasel, of course you could play that on repeat on YouTube. So whenever I see an x-squared function, the first thing that I do is I think, can I solve using factoring? Because I like factoring. To me, that's my favorite. And some people don't think that. But I would factor this into x plus 6 and then x plus 2. And then if I wanted to find the zeros, I would say x equals negative 6 and x equals negative 2. These are my zeros. Okay, so factoring to me is the route that I chose to go. Let's say you don't like factoring very much. Well, on any x squared, you can use any x squared, only x squared. Notice I put it in this little yellow star, only x squared. You could also use the quadratic formula. So the quadratic formula, as listed there, x equals negative b plus or minus. This is how we get two answers. These are quadratics, so they have two answers. Okay, look at this, two answers. Plus or minus the square root of b squared minus 4ac all over 2a. So then it's important that you recognize A, B, and C. And you're like, Mrs. Vogt, you highlighted nothing in pink there. This is a 1, okay? So A is 1, B is 8, C is 12. So as I start filling in my formula, I get x equals negative 8 plus or minus the square root. You should always put this in parentheses, b squared minus 4 times 1 times 12 all over 2 times 1. Okay, so one step at a time here. Plus or minus the square root. This is 64, and 4 times 12. 4 times 12 is 48. All divided by, and 2 times 1 is 2. Okay, 64 minus 48 is 16, so I have negative 8 plus or minus the square root of 16 all over 2. Okay, you're not done. Square root of 16 is 4. All right, plenty of students stop here and they're like, hey, look, Miss Vogt, I got an answer. No, you don't. Okay, these are numbers, and these are numbers you can give me. Okay, so what do I mean? I can split this into two things. Negative 8 plus 4 over 2 and negative 8 minus 4 over 2. That's what that plus or minus means. It means like I can add or I can subtract. So negative 4 divided by 2 here, negative 2. And negative 12 divided by negative 2 is negative 6. I hope you noticed something here. Whoops, I didn't want to do that. This one and this one are the same as this one and this one. So, does it matter if you choose quadratic formula or factoring? Oftentimes, no. If you do them both correctly, you should get the same answer, okay? Because no matter what, this x squared plus 8x plus 12 has the same two zeros. It crosses at negative 6 and negative 2. I could probably draw you a picture. Negative 6, negative 2, and I bet it looks something like that, okay? So why do I have an option? Well, there are times when it doesn't work to factor. So in my little solving quadratics toolbox, see, I put solve using factoring. That's always my first choice. I look here and I think, can I factor? Factors of 15 that add to negative 4. I cannot think of one. All right, so I'm going to have to solve using the quadratic formula. So I still have it written there, and then if it helps you write these out, A, B, and C. All right, so x equals negative 4 gives me a positive 4, plus or minus the square root. Again, you should put a parenthesis around that. All over 2 times 1. All right, let's take this one step at a time. I have 4 plus or minus the square root. This is 16, right? Negative 4 times negative 4 is 16. And then 4 times 15 is 60. So I've got 16 minus 60 all over 2 times 1, which is just 2. So I'm going to just write 2 there. All right. What is 16 minus 60? Being careful of my signs, I get negative 44. Plus or minus the square root of negative 44 all over 2. All right, so I have a negative square root. Okay, that means that I have an imaginary answer. That's okay, because that means this never crosses the x-axis, but you need to be able to handle imaginary answers. Okay, before we move forward, I want to tell you something that's very, very super duper important. Okay, you may not divide these numbers together. Okay, you may not divide something inside a square root with something outside a square root. So maybe off to the side you should write this. Negative 44 divided by 2 under the square root is not the same as square root of negative 22. You 100,000,000,000% cannot do that. Okay? I hope that you remember you did this in geometry, that you can simplify this. So I've got negative 1. I'm going to pull that out. It's really hard to read. Times 4 times 11. And why did I do that? Well, I know that 4 is a perfect square. So this simplifies to I, right? This simplifies to 2, and this part doesn't simplify. So how do I write this out? My next step is I have 4 plus or minus 2i root 11 all over 2. At this point, I don't think you're quite as tempted to divide the 11 by 2. What you can do, now it is okay, is if you have both of these, look, it kind of makes a heart. If it makes a heart, you can do that. 2 plus or minus I square root 11. These are your two zeros. It means 2 plus I root 11 and 2 minus I root 11. Those are my two zeros, okay? Guess what, guys? These two zeros, this equation matches this picture from way up here, okay? Where are these? Okay, well, they're imaginary. They are here. Okay, so I may link a couple more videos if I remember correctly, reminding you how to, let's see, simplify radicals and imaginary numbers. Okay, so if you're struggling with that part, you may want to check YouTube for more videos in case Mrs. Vogt forgets, which sounds like something she would do. The last bit of the quadratic formula is the discriminant. And the discriminant is kind of like a warning for you. Not in a bad way, but like it will tell you, hey, when you finish the quadratic formula, you should have 2 imaginary or 1 real root or 2 real roots. So the discriminant tells you the nature of the roots. So when the discriminant is greater than 0, you have 2 real. If it equals 0, you have 1 real. And it's not really 1 real, 1 imaginary. This is called a double root. And you have a real one that happens at the same place twice. And then if it's less than 0, you have 2 imaginary, or we could think of this as 0 real. And then I wrote this down. The discriminant is only the piece here, not the square root part, just the b squared minus 4ac part. Okay, the square root part is not part of the discriminant. It's just this part. So you still need to identify your a, b, and c. Whoops, 6. And then b squared minus 4 times 6 times negative 2. Another kind of like red flag, place mistakes happen, is right here. When you have a negative times a negative, what happens? It becomes a positive. So carefully, oops, that is not what I wanted. You're going to have 1 and plus 48, right? 4 times 6 is 24 times 2 is 48, and I have a negative times a negative equals a positive. My discriminant is the number 49. The discriminant is the number 49. And then you need to look at your 3 categories and ask yourself, is it greater than 0, equal to 0, less than 0? It is greater than 0. So this means that if I graphed this, I would have, what is the nature of the discriminant? Sorry, what are the nature of the roots? The roots? This is an actual question, so describe the nature of the roots. I have 2 real roots. And I know that because the discriminant told me. From here, it would be easy for you to continue by doing the quadratic formula because you already have that chunk under the square root, and it would be easy for you then to find the zeros. One last thing that I did not go over, and I want to let you know, is that you can program that TI-84 calculator on your Chromebook to do the quadratic formula for you. Okay, that's acceptable. Here's the deal. I'm not going to tell you how. You need to Google it or YouTube it. Can I use YouTube like a verb like that? I don't know. But you will find tutorials on Google and YouTube of people programming their calculator, and you can do the same. I would test it before I rely on it too much. But if you figure it out, you may use the calculator program. And that is it for topic 4.